for this assignment, we're going to be calculating different types of solution calculations. We've got molarity, mass percent, parts per million, and grams per liter. Now, if you pay attention, the chemical and the number of grams for each of these problems is the same for 1 through 5, but we're going to be calculating every single one of them differently. So for the first one, we need to know how many moles of solute. We haven't talked about this a whole lot, but basically a mole is 6.022 times 10 to the 23rd molecules. And what that does is it makes it such that our atoms that are normally measured in AMUs, which that's what this mass is, it's an atomic mass unit, that is way too small for us to even think about how much it is. So the mole, which is a quantity of particles, gets it such that the values on the atomic mass end up being in grams instead of AMU. So basically it's just the quantity to get it so that we can say that this is grams instead of a really small value. So to do so, it says we have 20 grams of NaOH. I need to find out how many grams are in 1 mole. To do that, I'm going to take the value of Na, O, and H. And for each one, for this molecule, there's only one of each. For the C6H12O6, there's going to be 6 carbons, 12 hydrogens, 6 oxygens. So for that one, you're going to have to take the value for carbon, multiply by 6, the value for hydrogen, multiply by 12, the value for oxygen, multiply by 6, add those all up. But in this case, we're going to use the NaOH. So it's going to be Na is 22.990, O is 15.999, and H is 1.008. So I'm going to go ahead and add those up, and I get 39.997. Well, I'm just going to go ahead and round that to 40 because I don't want to carry out 3 decimal places the whole time I'm doing the calculations. So I'm going to say 40 grams equals 1 mole. Okay, so now we need to take and convert, because it tells us we must convert our grams to moles first. We're going to convert from the 20 grams to get moles. So you can probably do that in your head, but I'm going to show you how you set it up. So 20 grams, and then I'm going to make a fraction out of this. So I need to put the 40 grams on the bottom because that's going to cancel, and then 1 mole on top. So my grams is going to cancel. I'm going to have 20 times 1 divided by 40. So that's what you would do if you're multiplying by a fraction. So we can really just kind of ignore this 1. So 20 divided by 40 ends up being 1/2 or 0.5 moles. So, and I probably should write that as 0.5. It'll be easier when we come over here. So now in order to calculate the molarity, I need to take moles of solute, which is my chemical, and I need to divide by the liters of solvent. So I'm going to have 0.5 moles of the NaOH divided by 1 liter. So that ends up just being 0.5. And molarity, we can say capital M, or you could just say 0.5 moles per liter is fine too, because that would be your label. All right, moving on to our mass percent. We're going to do number 1 again. So mass percent, we're going to take the mass of the solute divided by the mass of the solvent and multiply by 100. Now it says here, remember that water is 1 gram per milliliter. So for every milliliter of water, we've got 1 gram. And remember that there are 1,000 milliliters in 1 liter. That'll be good to remember. So for this one, I've got 20 grams. That's already my mass of solute. And I need to divide by my grams of solvent, which is my 1 liter. Well, 1 liter is 1,000 milliliters, and 1 milliliter is 1 gram. So then 1,000 milliliters would be 1,000 grams. And then I need to multiply by 100. So I'm going to take 20 divided by 1,000 equals times 100. So it's going to be 2% would be my answer for that one. Okay. On the back side, we've got parts per million. This looks almost identical to what we had on the other side. We've got our mass of solute, which is going to be our 20 grams NaOH, our mass of solvent, and remember again, that 1 milliliter is going to be 1 gram, so 1 liter will be 1,000 grams. So 1,000 grams times 10 to the 6th. So we'll have 20 divided by 1,000 equals times 10. And if you have an EE button, or there might be a times 10 to the power button on your calculator, you can hit that, and that's just telling you 10 to the power. I'm going to put in 6, and I end up with this for my answer, which is 200,000. And that's just going to be ppm, which is parts per million. Okay, and our last one is grams per liter. So we've got grams of solute divided by liters of solution. That's going to be easy because it's practically done for us on this one. So we're going to have 20 grams NaOH divided by 1 liter. So all it is 20 grams per liter. Done. So there's really not much more to do with that. On these other ones where your liter is not 1, you'll have to actually calculate it out. But for this one, since this is just a 1, we don't even have to calculate it because our label is going to be grams per liter, and since there was only 1, we're done. If you have any questions, let me know.